Video lecture 2.1. And here's just a refresher. Not going to describe this, just going to refresh us with some visuals. A simple review question from video lecture 1. Insulation at Earth's surface. Why does insulation, the amount of insulation one would find on Earth's surface, decrease as I go poleward? And you should know this answer. The answer is 2 reasons. Consistent day length, the fact that there's always that 12-hour day, 12-hour night, whereas on the poles it's much more drastic, but also the high sun angles, closer to 90, and so there's a greater presence of that 90 degree or close to 90 sun angle, combined with the fact that you have rather consistently long days, 12-hour day, 12-hour nights, plays a key role in why we see insulation decreasing poleward. Another review question from video lecture 1, you should know this answer. Where on Earth is water vapor the most abundant? And you should have told me it's along the equator in the tropics. And so previously we were looking at insulation, we had this idea, well wait a minute, it's decreasing poleward. However, if we look at this isoline map that showcases insulation, there along the equator they actually have lower amounts of insulation than they do along the Tropic of Capricorn and the Tropic of Cancer. So red being the highest amount of insulation is actually found there along the Tropic of Cancer and Capricorn, not along the equator. And so key to understanding that is the role of clouds, water vapor. Here we have our Tropic of Cancer and Tropic of Capricorn in equator. In the equator you can see that a result of that water vapor providing that dense green lush cover. This map showcases UV exposure at the surface, and we can see along the equator because of clouds they do a good job of blocking UV exposure at the surface, whereas further north where we have the absence of clouds, this Sahara Desert, you can see higher UV exposure rates, showcasing the role of no clouds in the absence of the filtering mechanism to filter out the UV rays. This is a bit of a review slide, but it's also going to end with a pretty important statement. And so coming in from the sun, that incoming solar radiation, we've got the shortwave and longwave. We've referred to this before, UV rays, we also have visible light, infrared, incoming insolation, solar radiation. But we also have outgoing. This key is we have these inputs, but we also have these outputs. And so re-radiating back out is low energy, infrared, thermal, long wave energy, and we can refer to that just simply as heat. So we can feel that. So the Earth, very important thing, the sun heats the Earth, but then the Earth heats the atmosphere. So very important. It's not vice versa. The sun heats the Earth, and then the Earth heats the atmosphere. So constantly the Earth, the surface, is gaining and losing energy. So that's going to be the focal point of where we're going to go on the next few video lectures. We're going to be focusing in on these gains and these losses.